Right, so what we do from time to time, we arrange customer days. On request, we've got companies that approach us and say, listen, we've got problem with our operators that are not as knowledgeable, for example, on the DMS cyclone side, classification, magnetic separation. DMS we normally take as a whole, and we do DMS cyclones, we do the whole circuit, magnetic separators, all of the equipment that's involved in that DMS circuit. And we give them a very good, highly technical session. And the outcome of that would be is that when that guy goes back to the plant, the operator, he actually understands how a DMS cyclone operates. One of the other problems that we find on the plants, the metallurgists are up on this level, the operators are down here, and the information exchange between those two are not as good. The metallurgists can tend to keep that information for themselves. And one of the examples that I can show you, this is a spiral plant. I'm going to get to a DMS type of application just now. But if we take spirals in a coal application, our guys in spirals have got experience, coal, chrome, all of the spiral applications that are out there. And they use all of that experience in putting together or designing a specific circuit, for example, for chrome. We've got chrome designs now that are up to, I think, 8 stages. Roughers, cleaners, treating the tailings, circulating the material back to get better efficiencies. And that comes from experience. You can't teach that guy that in a day. It's just impossible. Right, so for example, this is the comparison between 4-turn and 7-turn spirals. And I can give you another interesting example. We got to a plant, Adam's back at one of my colleagues and myself, and we had a look at the spiral section and something looked very strange. And what they did, they actually mounted the spirals on that A-frame angle, which was just, and you ask yourself, how will that spiral be able to operate properly if it's at an angle? It's impossible. And when we pointed it out, the guy said, oh shoot, I've never even thought about this. I walk past it and I see them, but I didn't realize it. And it's stupid things like that. The feed entry to cyclones, we normally, before we do the training for a specific plant, we walk through the plant. Milling, classification, thickening, the whole plant, and we go and see at the physical little things that you don't normally pick up. If you work at a plant for 10 years, later on you don't even see these things anymore. And then we point that out during the training, and then we go into more specific detail. This is on a classification cyclone, and these are the factors typically that affects that efficiency curve. Now, if I had to ask any young engineer, even if he's had 10 years experience, name all of those factors, he wouldn't be able to. So we go into each of these into detail, and we explain the physical parameters affecting that slope of efficiency and how to make it better. In a milling circuit, that is critical. If you've got a slope that's fairly poor, you're going to lose, or you're going to circulate a lot of fine material back into your mill, and you're going to waste energy. And you'll affect the leaching if it's a gold process. You'll take coarse material into your leaching section, and you will lose gold. It's as simple as that. So the outcome of this exercise will be able to assist the operators in understanding the classification process, making it more efficient, and at the end of the day, driving down costs. Right, so in any efficiency, be it screening of particle size, this is the ideal separation. If you separate fine material from coarse material, if I can separate it with a straight line, it's 100% efficient. And that's the problem with cyclones. You can never get that. But you can get as close as possible to bringing this slope to the vertical. So this material is going to the wrong side, that material going to the wrong side. And what we try and do, our cyclone engineers, we try and minimize this misplacement in both directions. There you can see the misplacement. So in a cyclone, the misplaced course will go to the overflow and the fines will go into your underflow. And you will always have that fines component in a classification cyclone being dragged with the water to the underflow. Unfortunately, it's there. But you can minimize it if you understand the operation of the cyclone properly. Right, one of the ways is to dilute your feed as much as possible so that you change the ratio of what we call the alpha water. You will reduce the amount of fines going into the underflow by diluting the feed. Okay, we've got two. We've got the standard correction curve and then the corrected one. What we do there, we take out that amount of alpha water. That's the water going to the cyclone underflow. We delete it from the equation. That will then represent what's actually happening in the cyclone and the fact that we can't do anything about the alpha water. Okay, then we'll get a D50 actual and a D50 corrected. The corrected value is normally what the engineers work with. Okay, so these are the typical subjects that we do within the training schedules. Cyclones, magnetic separation. What type of magnetic separation? One of the crucial ones are in DMS. And the reason why we focus on that is to minimize your media losses, be it ferrosilicon or magnetite. At a cost of 16,000 Rand a ton, ferrosilicon gets a bit expensive if you're running at 1.5 kilograms per ton that you're losing. And if you're treating 2,000-3,000 tons per day, it's a significant amount of Fezi that you're losing. And you will know our friends from South America, in iron ore, the Fezi consumption can become a bit of a problem if you don't control it properly. Then screening. We do wet screening, dry screening, the different types of screening, circulating loads, how it affects the circuits, and then the fundamentals of the specific screening operations, just to understand how the screen works and what the effect of that is on the operation. Spirals, I think I've mentioned something about that. Milling. Now the milling with the cyclones forms probably the heart of the operation. If you don't control that properly, you are wasting energy and you're wasting money. So what we sometimes do, we do what we call a milling survey. We take samples around the milling circuit and the classification cyclone. We go and analyze the results, the PSDs on those materials, and then we come forward with suggestions on how to optimize it. And that will include lifter bars within the mill, maybe the type of lifter bars, the mill linings that they're using, the specific cyclones, vortex finder, spigot relationships, what the D50 on the cyclone is, circulating loads, etc. So there's a lot of small things you can do to actually increase the efficiency of that milling circuit. Water treatment, that's one of our latest products that we've included. We can treat any type of water. Doesn't matter what it is. And there's two things basically you can do. You can either clean the water, or you might have a specific element in that water that you want to take out, that you can actually make money with. Ceramic wear linings. You'll see on our stand we've got a couple of examples. It's there for wear protection. So if you enjoy fixing a chute every 2-3 weeks, it's not a hell of a lot of fun. If you can get something in the power industry arena, we've got ceramic linings that have lasted up to 10 years. And the maintenance cost, right down. You don't worry about it. You install it and you leave it. For example, in the DMS cyclones, on coal, there you'd probably change between 3 and 6 months, depending on the particle size going through the cyclones, but those wear linings make a big difference on your downtime. It's critical. I'll skip one there. Filtration. Filtration has become a bit more important now that we've got legislation that says, listen, you can't just dump all of your rubbish out in the field. You've got to actually clean that water now. So in fine coal, we use filtration now, filter equipment. And it is important now because of the pollution effects, and in the other countries it's becoming also more important now. They're forcing people to do something about that effluent that they're throwing out in the field, in the environment.